What's up guys, I'm Nick Leonard, and today I'd like to talk to you about ACES Colorspace. So if you go to the Masterclasses tab on the website, scroll down and you can watch this course for free. So the first thing we need to do is go to GitHub and download the ACES config files. I'll click on the download link and download the zip. Once you've downloaded the zip, extract the contents, you'll get a folder like this. And I've just pasted that folder inside this PC documents. I've created another folder called Colorspace and just put it inside there. Just make sure that this folder doesn't get moved into different locations. It should always remain ideally in the same place. If you do move it, then you're going to have to update your environment files. Let's install ACES for Mantra first of all. So once Houdini is open, I'll go to the Render View tab. I'll click on this little section here. And this is where our color management is, and you'll notice there's no sign of ACES, and that's because we need to set up environment variables in the Houdini env file. I'll go to Documents, Houdini, and then version number, jump inside. We'll look for the Houdini environment file, right click, open with, and Notepad. Once that's open, the file should look something like this. I've also got some environment variable set up for Redshift, just so that loads the plugin. If you don't have that in there, that's not going to work, but we can talk about that later. So to get ACES working for Mantra, we need to type OCIO equals space, quotes. I'm going to browse where we put the config file. So in ACES 1.03, this is it here. Let's copy this location. I'm going to paste it, go back. Let's copy this name, including the extension. Add an extra slash, paste, and end that with quotes. I'm going to click Save, Control S. Close the environment file. Let's close Houdini. Reopen Houdini. Just wait for that a moment. Okay, we'll go over to the Render View tab, click on this box, and you'll see now that we've got ACES loaded in here, and the view transform is set to sRGB. We'll go to the Redshift tab, open the Render View, click on the cog, open the Color Management tab, and we'll change the display mode to OCIO. Where it says OCIO config, I'm going to browse where we put our ACES 1.03 config file. Let's load that in. And that's ACES for Redshift setup. Each time that you load Houdini, this might disappear. So what I do is I save a preset. I just saved a preset JSON file here. I just named it to ACES 1.03. And each time I load Houdini, then I just load the preset. Go to Windows, Settings, Preferences, we'll go to the Color Management tab, and where it says OCIO config path, we'll load in that same ACES config file. So mine was in Documents, Colorspace, 1.03 config. We'll tick this Use OCIO configuration, wait for that to load. You'll notice that the rendering space in the view transform has been updated, that's correct. We'll change this to OCIO standard rule, and I'll just reapply this rule to the scene. And then just hit save. So when I'm hovering in the node graph view, I'll just click S on the keyboard, go to the color tab, we'll change the color management from Nuke to OCIO, the config to ACES 1.03, and this does most of it for us. Working space, ACCG, monitor, sRGB. This depends on what type of monitor you're using, but for most of us, we're using standard RGB monitors, so that's fine. 8-bit files, utility sRGB texture, that's fine. 16-bit files, we can change this to utility linear sRGB, or we can change that to ACES-CG, but it doesn't matter too much as we can change this on the read or write node. Log files, leave as is. Float files, ACES-CG, that's fine. So what happens if we want to load these settings as the default each time we open Nuke? We can go to Edit, preferences, go to the color management tab and just change this to ACES 1.03. When I click OK, it'll ask me to close Nuke and reopen, so these are the new default. I thought it'd be a good idea to give you guys sort of a brief overview of the ACES workflow, all the way from the very start to the very end. So I'll run over this very quickly and then we'll go into more detail. So the first thing we do is input our textures into Nuke, whether that's a standard texture downloaded from the internet or whether it's something like a HDRI. We then convert those textures to the ACES CG Colorspace, and we then write out those newly converted textures to EXRs. We import our newly converted textures into a 3D software package. We'd enable ACES CG in the render engine. We did that earlier. We'd hit render. So our rendered EXRs are in the ACES CG Colorspace. We'd import them into Nuke. We do a lot of compositing whilst working in the ACES CG Colorspace, and then finally, right at the end, we would output that shot. There's a few different options for us, but most of the time you'd be wanting to use this option. You'd be wanting to output sRGB, as most people are using standard RGB monitors, including myself. And this completely depends on your target audience. So who is going to be viewing these files, because you might be working on a nice calibrated monitor with different specifications to other people, but your audience might be let's say university students who would typically own standard RGB monitors. Then this would be your option. So we've very briefly gone over the ACES workflow. So I think what we'll do now is just jump in and we'll go from the very start and explain this in a lot more detail. I'll delete these first 6 nodes and we'll recreate them from scratch. The first image we want to look at is an sRGB texture. And this would be an image typically downloaded from the internet, which would be a standard 8-bit image. So let's browse for that file. We'll go into the concrete sRGB, and this is a JPEG. I downloaded this from textures.com, so you guys can hop over to there and you can download it yourself. Okay, so the first thing we need to do is change the color space to utility sRGB texture. So this means that Nuke is interpreting this file as a utility sRGB texture. The next thing we need to do is convert this texture to the ACES CG color space. So the input will be what we've specified on the read node, which is utility sRGB texture, and the output is ACES CG. So we now have an image that's been linearized and is in the ACES CG color space. Let's drop down a right node and we can write out this image. Let's browse that same folder. I'll rename this to ACES CG and we'll make sure the extension is set to EXR. Just like that. Make sure the color space on the right node is set to ACES CG. We'll tick this write ACES compliant EXR, which forces a 16-bit half float file. I believe it turns the compression off. And we're good to render. Let's hit R on the keyboard. Let's re-import that texture back in. Whenever we import textures, we always double check this color space setting. So this now means that Nuke is interpreting this file as an ACES CG texture, which would be correct. So if I switch between these two, they're exactly the same. Okay, on to the next type of texture. So this is, or this would typically be a HDRI downloaded from a website, and this texture would already be linearized. So let's click R on the keyboard. We'll browse the HDRI folder and we'll load this in. So what exactly do all these names mean? Well, rooftop is the name of the HDRI. Linear sRGB states that this is within the sRGB color space, but the image has been linearized, so it has a linear transfer function. And all this terminology might seem a little bit confusing, but the more times you repeat this process, the more you understand it, basically. Zip1 scan is short for zip1 scan line, so how the EXR is compressed. 16-bit, so 16-bit half-float image, and 12K for the resolution. Let's load that in. And as always, the first thing we do is we make sure we set the color space correctly on the read node. So right now, Nuke is interpreting this file based on this setting as an ACES CG image, and that's wrong. This is within the sRGB color space, and it's been linearized. So this time round, we change the color space to utility linear sRGB. So Nuke is now interpreting this image as a linearized sRGB texture. We'll do more or less the same thing. We'll take a color space node and make sure the input is exactly what we defined here on the read node, utility linear sRGB, and the output is ACES CG. And if we switch between the two of these, you'll notice that the result is very subtle. And that's because they have slightly different primaries. And the difference between these will be a lot more obvious. Okay, so we now have a HDRI that's being converted to the ACES CG color space. Let's drop down a right node once again. We'll do exactly the same thing. I'll remove zip1 scan and linear sRGB, and we'll put ACES CG. And this also means that if anyone uses my files or jumps into my scenes, they know that this image is in the ACES CG color space. Let's also make sure that we're writing out EXRs. So always EXRs. We'll make sure the color space is set to ACES CG, the file type to EXR, write ACES compliant EXR, and we can hit render. Let's load back in that image, view it, double check the color space here. So Nuke is interpreting this file as an ACES CG texture, which would be correct. So if we jump back and forth now, that's right. One thing I'd like to touch on before we move on to importing these textures into Houdini is just a standard linear to sRGB workflow. So what we'd usually do for this is we drop down an OCIO color space node, and let's just use this as an example. We'll convert this standard sRGB image and linearize it. So the input would be utility sRGB texture, and the output would be utility linear sRGB. So if we switch between, we have a standard sRGB texture here that's in the sRGB color space, and now we have a linearized image that is still within the sRGB color space but has a linear transfer function. Let's take a right node, and this time round, let's just browse that file. We'll rename this file to linear sRGB, just like that. And as I said before, this now means that if someone jumps into my scene or they're using my textures, they know that this image has been linearized, but it's still within the sRGB color space. We'll make sure we're writing EXRs. The color space target is utility linear sRGB. We can leave the compression as zip1 scan line, which is sort of industry standard. And we can leave this as 16-bit half float. Let's hit render. Cool. Let's re-import that image. And as always, we need to change this because right now Nuke is interpreting this file as an ACES CG texture, and it's not. This is in the sRGB color space, and it's a linearized image, so we change this to utility linear sRGB. Switch back and forth, and that's looking good. So now we've got 3 different images, 2 in the ACES color space, and the other image in the sRGB color space, but linearized. I'm using Maya LT and not standard Maya, so I'm not going to be able to show you the rendering side of things in Arnold, but I will be able to show you the importing textures and setting up your shaders correctly. Let's open up the Hypershade. I'll drop down a file node, and first of all we're going to import the concrete texture. So we'll just rename this to something like concrete ACES CG, for example. Not oncrete, make sure it says concrete. We'll make sure the color space is set to ACES CG. And as we discussed a moment ago, Maya is interpreting the file we're about to load in as an ACES CG texture, so already in the ACES CG color space. Let's browse for that concrete texture, which has been converted. We'll drop down a Fong, or in your case, this will probably be something like an Arnold material, and we'll plug the out color into the color slot. And that's pretty much it. Let's import our HDRI. We'll rename this to something generic like a HDRI ACES CG. Exactly the same setting. So Maya is interpreting the HDRI in the ACES CG color space. Let's find it. And at this point, you plug the out color into a sky dome. And that's pretty much it. When you open up the render settings, you just have to make sure the input display transform is set to ACES CG, which is set automatically via the Maya color management, and just make sure the output display transform, the viewing transform, is set to sRGB ACES. And if you're struggling with this next stage, you can watch the rest of this tutorial where I'll be setting this up for Redshift, and you can sort of deduct from that workflow of how to do it in Maya. Let's go to File, set the project. So locate the project wherever that is on your hard drive. Click Accept. Let's load the Houdini scene, like so. I've just created a basic render cam, a very basic sphere, an empty material network, so there's no materials inside, and an empty ROPNet. The first thing we'll do is drop down an RS light dome. We'll rename this to linear sRGB. We're going to test out a linear sRGB workflow first before setting up an ACES workflow, so we can compare the differences later. I'll drop the icon scale down to 0. We don't need to see it. Let's go to the shader tab, load in our texture, and we'll make sure we're searching via this relative path here. So $job, source images, HDRIs, and we'll load in the linear sRGB. Just going to transform this around, rotate it, something like, yep, something around that is fine. We'll go to the shader tab, and I'll up the exposure to something like 3 for now. Let's jump into the materials. We'll drop down an RS texture, and this node will be used to import our concrete texture. So we'll call this something like concrete linear sRGB. We'll also create an RS material. Drop down the base properties, and we'll plug this into the diffuse color. We'll rename this material to linear sRGB material, just like that. Change the BRDF to GGX, roughness to 0.55, and we can leave all the other settings as is. In between the RS texture and the RS material, I'll drop down an RS triplanar node, as our sphere doesn't have UVs. We'll apply this material. I'm just going to drag it on top. Let's jump into the ROPnet, and we'll create a Redshift custom ROP. Let's rename this to sphere. I'm going to browse for the render cam. Click accept. We'll leave the render settings as they are for now, that's fine. Let's open up the Redshift render view. I'm just going to scale this window down. Let's click on the cog. Make sure the display mode is set to sRGB for a standard linear sRGB workflow. And I'll hit bucketed rendering. Let's just make sure that stays as sRGB there. I've also forgotten to input the concrete texture, so I'm going to do that. Just going to pause the render. Wait for that to load a moment. It seems to be taking its time. Click off that. Okay, here you go. So searching via the dollar job. Source images, concrete, and we'll load in the linear sRGB version. Back to the Redshift render view. Make sure we've got this display mode set to sRGB. And there is our linear sRGB workflow. At this point, I'll save an image as. I'll put this in images, render view, and we'll save this as a JPEG. We'll call it sphere underscore lin sRGB. Underscore v001. Yeah, that's fine. And we can stop the render. I'm going to close that down. We're going to copy and paste this light now. We're going to turn off this linear sRGB light. Let's turn it off. We're going to rename this to ACES. Oops. ACES CG. Let's change the file to the ACES CG version. So we're now loading in a HDRI that's in the ACES CG Colorspace. We'll leave all the other settings exactly the same. Jump into the materials. We'll copy all of this, paste it above, rename this to ACES CG material, and also this to ACES CG. Let's load in our concrete texture that's in the ACES CG Colorspace, and I'm just going to drop that on top now. Open up the Redshift render view once again. I'm going to pause it. Make sure the display mode is set to OCIO. View transform to sRGB ACES. Let's hit render. Turn on bucket rendering. So now we got this image. And this is an ACES workflow. I'll save that image as in the same location. We'll rename this to ACES CG. Click Save. What we're going to do now is demonstrate a very incorrect workflow, and I think this is adopted by a lot of people, and I used to do it myself when I first started out in CG, so I thought it'd be worth mentioning. Let's jump into the materials. Let's copy and paste this linear sRGB block here, paste it. I'm just going to rename this now to sRGB. sRGB. Let's load in the image that was downloaded from the internet, so the JPEG. And just to reiterate, this is definitely an incorrect workflow. Let's apply this material. Go back out. We'll turn off the ACES CG light. Turn that off. Turn on the linear sRGB light. And the reason I'm leaving this light dome with the linear sRGB texture in is because usually you wouldn't have much control over this. Usually you download this texture online and it would already come pre-linearized. So it makes sense just to leave it as is. Let's go to the Redshift render view. Pause the render. Let's switch this back to sRGB. So we're working within the sRGB color space, but we haven't pre-converted or pre-linearized our texture, which is very bad. It's very stubborn. It wants to jump back. Okay, I'll save this image out, and we'll save this as sRGB. Stop render. I'm going to save this scene as I've opened up the three images in Windows Preview. On the very left, we've got our sRGB workflow. In the middle, we've got our linear sRGB workflow, and on the very right, we've got our ACES workflow. So with the ACES version, we can see straight away that there's a lot more range in the highlights here. There's less blowout, more information retained. The shadows aren't as lifted as this linear sRGB workflow. And just generally speaking, the CG feels a little bit more grounded and more integrated. This also means that we can pump more light into the scene with an ACES workflow, resulting in a more photoreal looking image. In the linear sRGB image, the sky is blowing out, less information in the highlights. The shadows are very lifted. And then on the very left, the HDRI is exactly the same, but the concrete texture is wrong because the texture hasn't been pre-linearized before it went into Houdini. And you might think, oh wait, that's fine, it's just a little bit lighter, but you have to remember that if you don't pre-convert your textures and linearize them, the materials respond to light very differently in your scene. It also means that you can't push as much light into the scene as you would be able to with an ACES workflow, and that sort of results in a less photoreal looking image. I'm going to quickly render out the ACES CG version. Let's turn off this HDRI. Turn back on the ACES CG HDRI. We'll drop the ACES material back on to the sphere. Change the color space back to OCIO. Make sure we've got the render cam selected. Like so. We'll pause the render and I'll save this image as, we'll save this in Redshift as an EXR. We'll call it sphere _ACES CG, and it's very important to add the color space in the name So like I said earlier, if someone comes in and takes your files or they pick up your scenes, they know that this file is in the ACES CG color space. Just name it V001. Hit R on the keyboard. Let's import that render that we just rendered out from Redshift. Images, Redshift, Sphere, ACES CG. Okay, so we have an ACES CG image. Nuke should interpret this image as ACES CG, so that's correct. So when we've imported our renders into Nuke, we should be working in ACES, the entire comp. And let's say, for example, we've done a load of compositing, added our color corrections and whatnot, and we're ready to output this image or the shot. We drop down a right node, like so. Let's browse where we're going to put this image. We can put this in composited images, and we'll call this sphere underscore composited underscore V001, and we'll write out a JPEG. Turn the quality all the way up to 1. Subsampling to 444, so it's virtually lossless. And this is very important. And this is the only time that we need to use this setting. And it's when we're outputting our shot. So this time we go to output. And in my case, I'm going to output sRGB because I'm working on a standard 8-bit monitor. And most of my target audience as well will be using standard RGB monitors, so this makes sense for me to choose this option. If, for example, you were writing this image out and the intended target was something like an ultra high definition television, then you could use this Rec 2020, but I argue the case that how many people are going to be viewing this image on an ultra high definition 4K TV. So it makes sense to go with output sRGB. So at this stage, we're pretty much done. We can hit render. And that's our shot rendered out in the sRGB color space. Let's read that back in. You'll notice straight away that it's darker. And that's because, like we said earlier, we need to always double check the color space setting. So by default, Nuke is interpreting this image as a utility sRGB texture. But it should be output sRGB, which is what we set and defined on the right node. So this is the final stage, and this is when you use this out sRGB setting. Let's also check that image in Windows Preview, just to make sure that they look exactly the same, and they do. I really hope you guys have enjoyed this tutorial. I've had a lot of fun making it, and I really hope that this has helped you guys understand that little bit more about the ACES workflow and a linear workflow in general. Keep testing out different lighting situations, test out different textures, change the HDRIs, come up with something new, and it's a good way to learn by making mistakes, so don't be afraid of it. You may find in a lot of cases that your scenes are really, really dark, and that is actually correct, so don't let that put you off. It just means you need to pump more light into your scenes. If you guys struggle with anything, or you need clarification on anything, then email support@pixelfront.co.uk and we will try our very best to get back to you. Thanks again for watching.